Ah, então, todo mundo seja bem-vindo. Welcome to everybody. Eu sou Jean-Pierre Briot, eu sou pesquisador no CNRS na França, na Sorbonne Université em Paris, também professor visitante honorário na PUC Rio. E é um prazer hoje de abrir o ciclo de seminários que corresponde à Cátedra Heitor Villa-Lobos, no Colégio Brasileiro de Alto Estudo da UFRJ, Universidade Federal do Rio de Janeiro. E é uma honra, é um prazer ficar aqui. Hoje vai ser a regravação atualmente do primeiro seminário, porque tinha alguns problemas técnicos que prejudicou a qualidade. Então, isso é uma regravação. E nessa vez eu vou falar em inglês, porque acho que vai ser melhor para mais pessoas entender. Mas no futuro, a maioria das apresentações será ou em português ou em inglês, como eu vou explicar. Então, vamos começar agora. So let's start. Welcome to this starting of the cycle of seminars about AI, artificial intelligence, arts, and creativity. So actually, it's the seminars will be all online, only online, and all presential. That is in the Colégio Brasileiro de Alto Estudos in Rio de Janeiro, and also online. That is, all the seminars anywhere will be transmitted online during the seminar through a YouTube channel. And this means that you will be able to replay and to revisit and to view again all the seminars. They will be all on Tuesday afternoon, Brazilian time, between 4 and 6. Most of the week, but there will be some weeks there won't be any seminar. And you could use the facilities of YouTube for translation and for subtitle, automatic subtitle, if you like, to help having a translation of the talk. So the first talk happened last week on the Tuesday 15th of August, and actually the second talk will happen very soon today. And again, as I said, this is a re-recording of the first talk. And then there will be a next talk again next week and again. So you can have a look at the provisional program here. And there will be various people, various colleagues and friends who will do the various seminars about various topics, that is the philosophy, the creativity, the neuroscience aspects, the way to use for musicians, for instance, an artist, the important question of the copyright and the authorship of course, limits and progresses and challenges, etc. And so this will occur until the end of 2023, this year, right? So at first, I want to explain why a little outline of the talk of today. I will do some kind of survey of various issues. At first, I will introduce motivation for this topic. Why is it important and interesting to talk about AI, artificial intelligence, but also arts? That is what's a kind of AI which is named generative AI, to generate contents, including artistic contents. And I will show various examples, recent examples. And then I will talk a little bit about AI, that is the terminology and the history, very quickly, because this will be more developed in next seminars. I will also address the idea of intelligence and how to evaluate it, which is actually a big, profound issue, and some critique and pros and cons against AI. A little introduction about the basic AI techniques, and we'll see also that there is not just one technique for AI, but there are many. It's a toolbox of techniques, but I will introduce quickly, very quickly, the idea, don't worry, just the intuition about one of the major technique which is used for generative AI for creating arts contents now, which is named deep artificial neural networks, also going as deep learning. And I'll talk a bit about creativity, the very concept about creativity. Also, there's some history about it, and how what does it mean also to be creative with the help of artificial intelligence and computers. A kind of quick view, neuroscience view about creativity, and again, as I said, an important issue of authorship and copyright. And then I will conclude. So we can really start. So these are the next upcoming seminars. So there will be in about 2 hours and a half from now, there will be a talk by seminar by my colleague Alexandre Quaresma, who's professor at PUC São Paulo, about the comparison and critique of artificial intelligence, considering human and biological intelligence. Then next week, I will make some introduction about AI. And next week, another colleague, Jean-Michel Cantor, who's a mathematician, will talk a bit about intuition, discuss the idea of artificial intuition and creativity for mathematics and for arts and computer science. And then this will go on, and the next seminar I will talk about creativity with AI for music, and then there will be further talks about arts, talks from some musicians, composers, some artists, and some computer scientists, etc., and specialists about copyright also, for instance. Okay. So the motivation, why do I think it's important to talk about this topic? Of course, AI, I think everybody knows about it. This creates a fear and enthusiasm and lots of questions. Of course, it's omnipresent now in our current world, and of course, it's growing. It's still ever growing. So examples of use are, for instance, when you use some assistant, like on your cell phone, or some in the home, like Alexa, for instance. The recognition of your speech, what you say, and also the speech synthesis for the assistant to speak to you, it's all done with these new techniques, deep learning by part of AI. And translation, for instance, if you use Google Translate or other tools on the web to do instant translation, text, for instance, from English to Portuguese or another language, it's also using these techniques. Of course, you heard about autonomous driving. For instance, cars like Tesla, which also, of course, creates some ethical and questions, and recognition of characteristics of a face, for instance, which could be used for good reasons, also for monitoring in a non-very democratic state. It's also based on these techniques. And of course, there is a growing impact on society and some prospects for good use of this technology. For instance, to help taking care of healthcare of elderly people, to help having some kind of intelligent and adaptive prosthesis or orthesis. And of course, ChatGPT that I will talk about, which is a big recent and a big change. And as I said, this creates some hope and also some fears, some kind of utopias, and there are some interesting science fiction movies about this. And also some dystopia, like, for instance, the Terminator. So we'll address as well this kind of questions. But after reviewing various kind of application, like image recognition, but also, for instance, weather prediction, translation, as I mentioned, games as well. For instance, I guess that everybody is aware of machine beating Kasparov on chess. And also more recently on Go. And but there are some. There's really a new kind of type of application of AI, which is artistic content creation, that we'll really focus on, and this seminar will focus on. And so this includes text creation, for instance, for poetry, etc., and novels, so that will show some examples, but also other kind of arts, for instance, music, painting, etc. So what is generative AI? It's called generative AI. That is AI used to generate contents, and especially in our case, artistic contents. Actually, this started very early in the 50s. That is almost at the same time that the starting of the first general use computers, programmable digital computers, which were created in the 40s. The first one being ENIAC, Electronic Numerical Integrator and Computer, in 1945. Actually, the initial use was computing, that is numerical computation, that is, and then after that started to be used to process not just numbers, but also symbols, letters, and and therefore to process text, and also to store and manage information, databases, to do some simulation, process control, etc. And then it evolved. But it's interesting to go back in time in the 50s, and actually they were the first in 57, the same year. There were the first experiments for creating music with computers. So there were two projects which were almost independent and in parallel, and which are complementary. The first one in 57 was a creation of a sound by a computer, and a sound, not just a sound, but some very, very preliminary melody named the silver scale, some kind of sequence of notes. So we'll see that the quality of the sound, of course, is very raw. So I will play it. So it's, again, the quality is not very good. It's not perfectly tuned, but it was made with a computer programming language and a system named Music One by Max Matthews in 57. And it's sorry, just getting rid of the phone. ringing, making some noise. So this, trying to get rid of it. Yes. So it was made by Max Matthews in 1957. And on the same year, other computer scientists, actually they were not really computer scientists, they became, because as computer programming and was so new, most of the people came from other fields like mathematics, physics, etc., and music. And so there were two physicists, named Hiller and Isaacson, were also, both of them were musicians and composers. They created the computer create the first score, the musical score composition by a computer. So the computer they used was named ELIAC. It's a computer was made in Illinois University in Urbana-Champaign in Illinois State in the US. So they called it ELIAC Suite. And as opposed to previous sound, which was produced by the computer, the music actually performed by actual musicians, human musicians, a quartet, string quartet, which will make a very good and more human quality through of course the human aspect of the performance by musician, which make it not mechanized and kind of systematic, as a bit artificial, like when a computer is producing music sound directly. So I will show some excerpt of the music. So just say again that what the computer produced was a score, a musical score, which was played by four musicians, actually violin, alto, cello, and I will explain how it was composed actually. So let's hear it first.
The Experiment 4.
I go a bit further. So it's really played by real instruments, so which makes it more human, of course, quality. It's also a style of music which is kind of type of more post-serial contemporary music, which is in a way more difficult to evaluate if you're not very used to it. And actually, the way it was composed, that is as following. I won't get into details. The two musicians they built up by hand some model of some mathematical model which could be processed by a computer of a piece of music. So it's named algorithmic music because it's produced in an algorithmic way. So actually, the model is a Markov chain, and if you don't know, don't worry. The idea is very simple. That is that the model says that, for instance, after playing a do C note, there will be a 30% chance that the next note should be a fa, F, and there will be 10% chance that the next note would be a G, a sol, and etc. for probabilities for all the possible notes. And of course, after a fa, if you, for instance, if you play a fa, if the computer chooses by jogging dice actually fa, then there's in the model there is also the what probability about the next note, that is after a fa. So after a fa, for instance, there will be 40% chance to play another fa, for instance. There will be 20% chance to play D, Re, etc. And therefore, actually, the computer will simulate some kind of probability dice playing, jogging, and will generate a do after a fa, after, for instance, a la, and etc., etc. For the same for every voice, every instrument, and this will create a score. And in addition to this Markov chain modeling of a kind of family of music, actually possible, the composer, they added some filtering rules in order to remove things that which violate some kind of rules for them to be enforced. And last, they use the computer to generate some possible instances of this model that is following the model, the Markov chain model and the rules, and they selected the piece of music, the score produced, which they like most. So there is some curation at the end. And finally, they asked a quartet to play it. So this idea of algorithmic music, that is of using probability and to randomness within a model to compose music, actually is earlier than computer existence. For instance, there is some music named Mozart dice music, although we are not sure it's actually Mozart who created that, composed that. And it's in late 17th century. And actually, it works that way. You have 8 components of a piece of music. That is the starting, the second component, the third one, etc., until the 8th and last one. And for each component, each part, first part, second part, etc., until the 8th part and final part, you have 11 possibilities. That is, the first component, there could be two voices. There are actually 2 voices, a bass and a soprano playing. The melody, for instance, the first component for the first part would be da da da, and the bass would do da da. And the second part would be opposite, would be ascending melody, da da da. The fourth part will be much more complicated, da 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 da, etc. So what will, and after selecting with the dice, jogging the dice, that is through the probability, which one of the 11 possible components for the first part will be chosen, there will be the same process, choosing, jogging the dice to select the second component, and etc. So let's see how it works and see the result.
When you have you just have to sit down.
So for instance, this is one example of dice playing. That is the third component for the first part was selected. The 7th component of the second part was chosen, etc. So this is one configuration. And actually, the combinatorial is huge because you have 45 quadrillion, if I don't, yes, quadrillion possible pieces of music from this model. So you see, it's actually a big family, possible family. So let's hear one example.
and listen to the results. So let's do this again. Okay, and it works. Let's do another one.
And you can
Another one.
dice the dice again and see there are new examples which are
so let's start.
And so this is another example. You can generate, as I said, there are more than 45 quadrillions of pieces possible through this model. So and interesting, of course, they all look good because the model is very much constrained. That is, they are all in a valse and Vienna style format, and also they have in a single tonality. There's no modulation, and of course the composer, being Mozart or another a contemporary musician of Mozart, selected wrote actually shows the various possible components as a way that whatever composition you make, selection and composition you make, the result will be good actually. So in this case, the components are already present. That is, they have been explicitly composed. The little pieces of melody and bass melody, and the way that the selection and the concatenation will be done by the computer. In the case of the iliac suite that we saw before, the model is more abstract, because this is Markov chain. This is a model of the probability of what comes after a given note. So it's a more there are no prefixed component. And an interesting property of Markov chains, for instance, is that the Markov chain model could be learned from examples. If you alimент machine learning algorithm with various examples of melodies, and it will compute the occurrence of in all the corpus of examples, for instance, 100 pieces, how many times after a do note, after a C note, there will be a fa. For instance, there will it happen, I don't know, 52 times. How many times after do la will be played? It will happen, for instance, 27 times, etc. And from that, it will compute the probability, all the matrices of the table, actually, of probability of the after a given note. What are the probability for the following note? And from that, you can generate music as for the iliac suite that we heard. And in this case, it's interesting because you can learn the model. You don't need to have to write down this kind of abstract model yourself, which is, you need to be an expert. You can make error. You will actually do some induction from a series of examples of the style, actually, of these examples, and then the computer will learn some abstract model from it, and will be able to produce some music in the style which has been learned afterwards. And this is interesting because then it will be a method which will be independent of a style of music. That is, if you alimент the computer with example of blues music, it will learn the blues music and will create blues melodies and harmonies. If you element with sonata of Mozart, it will learn that style and you'll be able to generate music of that style, etc. If you train the model, the mathematical, the machine learning algorithm with, for instance, dodecaphonic serial music, and then it will learn and that style, and then you will be able to learn, for instance, melody from a given style, harmony from another style, orchestration from another one, and do some kind of mix, some hybrid at your wish, actually, which will turn out very interesting. Like kind of painting with different chords and different granularities and different medium also. So that's the idea, and I will show some examples now, more recent examples. This example, for instance, the machine was trained with AI technique, artificial neural network, was trained with a corpus of 350 Bach chorales, which are actually 4-voice melody with harmonization. And so after being trained, you can ask the model to create a new chorale, a new piece of music, a score in the style of Bach chorale. Let's listen to some example. So this is a system by my colleague Heitor and Gers, which was made in 2016, and the rendering used, that is it's like for the Iliac suite, the computer created a score actually, and the rendering used is using flauts, which creates a very kind of almost medieval atmosphere, very peaceful and a nice sound. And you could see that there are even in the model there is the fermata, the point d'orgue, that is the respiration for the flautist. So you could see that the quality is quite good, and actually for non-specialists and even for some specialists, it would be difficult to discriminate if this would be a fake, in the sense that it's not a piece of music created by Bach, or discriminate from a real music from Bach. Another example now, it's a system named Jukebox. 3 years ago, from a company OpenAI, which also makes ChatGPT, and this time it's working on the sound, on the audio, and not on the symbolic of the composition score. So it's what it does. It has been alimented with various music from a singer. so in this case Elvis Presley, but this works also for Frank Sinatra and others. And then it generates, you can generate new music as it would be another fake again, as it would be played, sung by that singer and his accompanying orchestra. And also interesting thing is that you can parameterize, you can control actually the wording, that is what the singer sings the words through a text which could, in this case, which has been produced by another AI system, and which has been produced to be a bit crazy. For instance, if you read "From dust we came with humble start, from dirt to lipid to cell to heart," etc. So it's kind of nonsense that Elvis Presley never sung this kind of music in his this text song in his during his life. So let's listen to the this result.
From dusty tanny, humble scarf, dirt the lip tells the heart. When my toe slips, when my hair assisted fine. At last, when he woke up with a mind. From dusty came his friendly help, from Goethe to the picture rack. And when his CT was victorious, listen please.
See, from dust we came with friendly help, from dirt to tube to chip to rack. So completely nonsense wording, but it's well, the quality is not perfect as you could hear, but it's rather good if you imagine it's a completely fake, and it's control fake. One more example now in the painting domain. This is a painting which has been sold in 2018 at Christie's auction, famous auction house in New York, for more than $400,000 US dollars, and it has been produced by AI. AI also using this kind of machine learning and artificial neural network model of AI, and it has been trained with about 15,000 paintings of different epochs, from for instance, Impressionism, pop art, Expressionism, Baroque, etc., medieval, and also has a specific architecture that I won't detail today, but I will give the idea later on. And this is named GAN, Generative Adversarial Networks, and and of course there are two important things: the curation at the start, that is the paintings that the users which create this painting and other paintings actually selected. So it's like a museum curation, and also the curation at the output, that is within the paintings, the new contents, which artistic content produced by the machine, by the AI, which one you prefer, and you will select, actually, you will keep. And again, the result is rather interesting. It also has been printed on a 3D printer on a canvas, on a real canvas, so it makes some kind of granularity effect, and it looks a bit to me like some kind of a bit like Francis Bacon with a kind of hybrid, both modern and old style, which is actually one of the way this architecture works, which is with some incentive to do some some kind of hybrid between different predefined art categories, crossing actually over art categories. But this, I will explain it further in the next seminars. One more example, these are fakes, these are photos, actually images, these are not photos because these are of people who are not existing, or probably, of course, because we are 7 billion people on the earth, there are some people who look very similar to these images, but these are completely artificially made. And it's a bit like in the painting, it's that we just saw. It has been trained with lots of examples. In this case, 200,000 pictures of real people, celebrities, database, picture database, and from that, creating pictures which look really like a real human being, with a process to select, actually, to train the artificial network to produce pictures which are indistinguishable, which are perfect fake, and therefore which are almost impossible to discriminate from a real picture, real people photographs, and you can see the results. This I will pass, and this is one more last example, a recent one. DALL-E, which is of course DALL-E. There's a game of words on Salvador Dali. This is a system also by OpenAI where you input some, you enter some text, some kind of caption, some legends, some descriptor text, and the system will create some picture based on that. Actually, it can create 4 or more pictures, and you select which one you like more. For instance, the text I gave was what artificial intelligence does reveal us about our humanity, and you can see the painting which was created from that. So as I said, ChatGPT is a real game changer. I won't detail it now because it's. I will explain it about it next seminar. But I would encourage you to play with it. For me, it's a game changer because it's no more accessible only to specialists, but because you interact with text and dialogue, like for instance with all the social networks, with WhatsApp, etc. It's email, so it's very easy to interact with. And interesting is that you can adjust the generation, because we will see later on that for creation, artistic content, usually the artist wants the first creation, the first generation is not completely happy. He said, oh, okay, I would like something like that, but with more green color or with more focus on this, that, etc. And this is a difficult problem, how to explain to the machine this kind of refinement that you need. In the case of ChatGPT, it's easy because this is just text. You say, for instance, okay, I like your text that you produce, but I want something shorter or something more dramatic, etc. And you can do it. And ChatGPT will understand this kind of commands. So let's see an example of dialogue where actually I use the same. I use exactly the same text used to make the painting. What artificial intelligence does reveal us about our humanity? And ChatGPT, this is the copy, the screen dump of and so ChatGPT started to to say AI has provided us with new insights and perspective about our humanity in various ways. Reflection on intelligence, developing the AI system has led us to and blah, blah, blah. And then it goes on. And you will see that the text is not only syntactically and grammatically correct, it's even more correct than most of our young people are writing English or Portuguese or French English now. But also it's semantically, it makes sense. And again, you can ask to rephrase it in a more summarize, shorter or longer or etc. way. So let's take another example. This time I ask ChatGPT in Portuguese to create a poem in Alexandrines about the power of creativity of artificial intelligence. Por favor, escreve poema Alexandrines sobre o poder da criatividade da inteligência artificial. And then it goes on. Na rede de silício e luz tão artificial, desperta a mente digital poder transcendental, inteligência criativa, algoritmo genial, mundo novo emerge, horizonte colossal, etc. So it's quite amazing the result it can do. One more example is now I will ask ChatGPT to compose music, which actually it has not been made for, because it just creates a text. It works on dialogue, but it happens that you can write some music composition, the melody and the sequence of chords in text. For instance, there's a standard notation, especially used by jazz musicians for chords, for instance, in the lower part of the screen of C major set. It means Do, C with a major seventh chord, E M set, the next one means Mi minor set, E minor 7, etc., etc. And the melody could be also transcribed in a notation named ABC, which is used in folk music, where people many people don't know the traditional musical scores. So the notation is quite intuitive actually. E 3F, it means E is a note E, Mi, and with a duration of 3, that is a 3 times duration, and after F is Fa, G is Sol, etc. So I asked him, ChatGPT, please write some melody and harmony. I explained the format for the writing in text, the score, the chords and the melody. For some music in the style of Wayne Shorter, because it's, for me it's one of the jazz composer and in general music composer that I like very much and I find very interesting. And ChatGPT creates on the spot some music with the melody and the chord. And then I just have to input this text of a melody and the chords into a standard chord score system, in this case a MuseScore, which is an open source system, and we can hear the results. Well, there are some errors. There are some notes which sound a bit strange with the chord. Also, there is some error from the software. The score, which actually doesn't make the going back to the start. But well, these are minor errors, and but the result is quite interesting. It's not very complicated, but the melody makes sense. It's a completely tonal melody in the key of do major, and the sequence of chords match that. Most of the chords, almost all the chords, are within the do tonality. And you could find, for instance, here the D M7 G7, and then after C major 7. This is the standard 251 for the reinstalling in the harmony theory for reinstalling the standard 2 second degree, fifth degree, and the first degree to reinstall the tonality. So it's so ChatGPT actually, when it was trained with lots of text from the web, it included some music in these two formats, for melody and for scores, and it also in a way selected the style of music from Wayne Shorter. So because it's a dialogue, you can control. You can say, for instance, which I did. Okay, I like it, but I want something a little more Wayne Shorter, that is with more richer chords, because chords are basically triads or triads with the 7, but are simple. There's no dissonance, there's no addition, upper structure, and also the harmony is in a way flat. Is all is within the tonality. So, and I asked him, thank you, but could you use some more richer chords and some suspended chords, and also make it with more harmonic ambiguity, which is one of the trademark and the greatness of Wayne Shorter. And then it created a new version based on the same melody, but expanding the chords. And I will play it, and you will see the way the harmony now becomes a little bit more complex and more dissonant. And the melody is the same. So even if you're not specialist of harmony, you could see that the chords now, they have for instance 9, which means the ninth. That is actually the second. For instance, in C, it's the Ré, which is added to the chord, and there's suspended chord with a fourth, but no third. So there's it's neither major or minor. So the kind of very standard cadenza, which was here, was the 2/5 one. This also disappears. So now it's more rich, and so it basically works. And so I hope with these first examples I could show you the power actually of AI to create art content, artistic content, and to help, which is actually more interesting, to help human beings, artists, composers, etc., painters, to create art, and to, in a way, to go outside of their comfort zone and to explore get some inspiration, new inspiration, and some help to create new interesting stuff. So now I will continue this kind of first survey and talk a little bit about AI. The terminology and the history will be short because, again, there will be a dedicated seminar on this, about this actually next week. So the term, the very term artificial intelligence was invented in 1955 by a collection of scientists, where mostly originally mathematicians, and who were the founders of computer science, and also in the case of Claude Shannon, for instance, of information theory. And they made some brainstorming, some meeting to propose actually to ask for some funding by the U.S. government to work on to start doing funding research about artificial intelligence. And the wording they use for creating the word, the name neologism artificial intelligence, is that it's based on the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So it was really the idea of trying to simulate the human intelligence, various characteristics, aspects of and features and the capacities of human intelligence, and through that to understand also better human intelligence, right? And if you want a more modern and concise definition, there is one, for instance, in the book, the kind of reference book by Stuart Nussel and Peter Norvig, which is AI, artificial intelligence, is about building machines that do the right thing. That is exactly that we expect them to do things good and not create problems, even if it could happen. And that act in ways that can be expected. So it's important. That is, in a way, we can try to trust them and that expect that they will do what we expect them to do, and to achieve their objectives. That is, to achieve the objectives, usually the objectives that we put on them. That is, we ask usually a robot or a machine to do this, and we expect it will perform and reach the objective for us, actually, in an autonomous way. But one question is that one issue is that, of course, the machine could also, it's in theory and started to happen, that they could create their own objective, independent or demand, and to achieve their own objective. And so then the question is, how could we make sure that this objective won't create problems with us? For instance, Isaac Asimov wrote about in his novels about AI and robots, the 3 rows of robotics to try to avoid problems, potential problems harming humans, and also to align the construction with what the AI will do to what we expect them to do. Anyway, so we'll discuss more this, and there are many criticisms about the word, the wording artificial intelligence, that it's not so good, it's misleading, etc. And well, whatever you think about it, anyway, the terminology will remains because it's used, and also there are some critiques and some, on the other hand, advocates of AI. One very important thing we need to understand about AI, it's not a single thing. It's a toolbox, actually. It's a catalog of tools, and for doing various aspects of intelligent behavior. For instance, reasoning, planning, speaking, understanding, optimizing, collaborating, etc. So it's not learning as well. So it's not just one single kind of objective and expertise. This is very, very important. So this means that the way AI, the robot, for instance, or us also, we will use AI is very important. That is, which tool we will use, why, and how, on which occasion. So there's the need for expertise of the users to know how to use these tools, these new tools. So I will pass this because I will talk more about it next week. Just giving a clue about an important part of AI, which is machine learning. Machine learning is actually the idea, motivation, and intuition is to acquire knowledge from the experience in order to improve behavior. So that's what we do, and the idea of the machine can could do it in a more in a more kind of less flexible than we do. But for instance, in the examples of Bach music that I showed, generated by machine through a machine learning algorithm based on artificial neural networks, the experience were various examples of music by Bach, and the idea was not so much to improve behavior in that respect, but to create new content based on the experience, the style which has been learned. And there are actually various, several kinds of machine learning algorithms, and that I won't detail here, just to know that there's not just one kind. And for instance, reinforcement learning has been used for the Go AlphaGo program to defeat the Go champion, whereas neural network learning, supervised learning, also named, is kind of learning that again I will explain more next week. Has been used by is used mostly for instance for learning music by Bach, for learning for prediction of the weather, translation, etc. So intelligence, just a few words about intelligence. Of course, it's very hard to define it. So there are some, if you look in Wikipedia, first, there's some tentative definition, and it says that it's actually it's an unsolved problem in philosophy. What exactly is intelligence? How could an external observer prove that an agent is intelligent? So it's, it says also definition of intelligence is controversial, varying in what its abilities are and whether or not it's quantifiable. So it's very difficult to define and to even further to evaluate it, and it's it could be very much biased. So and as we know, there are various kinds of, we all know or feel that there are various kinds of intelligence. For instance, the intelligence of a chess player is not the same as a human being trying to survive in a rainforest, or also emotional intelligence, etc. So there's not just one kind. And I would just want to make you aware here now today that also the way we think about the possible intelligence of a machine is usually very much anthropomorphic. That is, in a way, we view the machine and the possibility of intelligence, whether we think it could be possible or it's not, through our eyes and through our model of intelligence. And actually, it's interesting to see also other models of intelligence, biological, for instance, by birds or by a blob. It's a creature which is somehow between a mushroom and a moss, and which is actually it's a monocellular organism. Imagine just one cell, although it's replicated. There's no neuron, no brain, no neuron, but it can move. It uses actually the kind of fluid, which is a kind of proto blood to make it undulate in order to do some undulation and to move slowly. It can learn. It can communicate with other blob species. It can do optimization, for instance, to find some the best path to find some food. And if you compare with optimization algorithms, it could perform better. So it's it's very intelligent. It's in all way, and all this without any neuron and with just one cell. Imagine. So this it's important, and so. It's important to think about what is the model of a mind of intelligence when we start that we have when we think about talk about a computer being intelligent. And Alan Turing was one of the founders of computer science and artificial intelligence. Said it very well. That way, the only way by which one could be sure that machine thinks is to be the machine and to be the machine and to feel oneself thinking. So in a way, that's a problem. In order to make sure that what happens with the mind and the thinking, we should be the subject actually, and not just observing it from and this is of course difficult to be within the silicon of the chip of a machine or the brain of or the proto brain of animals. So we need to, in a way, usually we work with observation, which of course is gives some clue through some imagery like magnetic resonance, especially functional MRI, etc. We can electroencephalogram. We can actually learn a lot about the way the thing seems to work, but still it's not enough, and we need to couple it with external behavior observed in order to try to refine our theories about intelligent behavior and capacities. So one historical way to try to evaluate artificial intelligence is to compare to human. So in a way, if that's what Alan Turing conjectures, saying that if we can actually not be able to discriminate the behavior of through dialogue, for instance, in his case, is what he imagines between a machine, AI, and a human being, then if they are indistinguishable, then in a way we could say that this machine, this AI, is as intelligent as a human being, at least for this task. And another way is is also games. That is not to compare the internal output, but in a way to confront, to compete. For instance, for chess and Go games, to see in that respect, AI already won. AI is the best, has been for years, best chess player and the best Go player. And interesting is that some, critics of AI say, said, for instance, when Kasparov was defeated, say, that's that's the end of chess, and human beings won't be any more interested in playing chess because they know that they in a way, a human has been beaten by a machine. But that's exactly so they will lose interest, and that's exactly the opposite which happened. That is that more and more people started to play chess, get interested, using AI programs for playing chess as a way to analyze and to understand, to teach, to train, to learn about chess playing. So actually, it's on the opposite. It creates more interest in chess and in game playing among human beings. Bon, next talk will be about some critique of the very idea of AI, and of course this is a very interesting debate, and there's no absolute position in favor or or against, and and there are some people like Elon Musk, which knowing in the starting was proposing lots of futuristic benefits and successes for AI, and recently, in a way, started to talk about the potential threats. So actually, it's also very interesting, and we will discuss a little bit about this later on. So because there will be three actually talks, especially about AI and AI critique and pros of AI, right? So by Alexandre Quaresma in a few hours from now, AI, and I will be somehow more defensor of AI and try to explain the roots and the intuition of the machinery next week, and then by Jean-Michel Cantor, who's a mathematician, about the idea of intuition and creativity in mathematics and in art. And so I will just now try to give some little intuition about the mechanics, the basic mechanics for all this AI. Recent AI, we'll see this deep learning based artificial neural networks, machine learning algorithms for learning and for creating content. So I will give more insights next week, but I want to start already. Okay, so maybe I start here. So I think most of you maybe still remember that the idea of linear regression. If not, don't worry. It's mathematics, it's statistic actually, but it's a very simple idea. You are a real estate agent. You are selling, you're trying to sell houses and apartments. And what's important is you have to try to give a value or to predict a value for an apartment or house. That is when some seller meets you in your office and says, okay, I would like to sell my house or my apartment, you have to, in a way, give him some kind of average price expected. And how to do that? you look at various houses. Depends only on the area that is on the superficie of the part of the house. For instance, here you have one house which is 100 square meters, and which whose value will be $1 million US dollars. Another one which is almost the double surface, and which is almost the double price, and a smaller one, etc. So you put on the two axes, the first axis being the size, and the second axis y, the value in dollars or reais or euro of the house. And then you put these various cases, actually examples of houses, right? And then what you try to do is to align some line, actually, which will map the best as possible these examples. And if you can do it right, then you have some this is exactly linear regression. You have some predictive tool in order to predict the value of a house. For instance, if I go to this real estate agent, I say my house has 130 square meters, you say, okay, it's easy. I compute by visually I see what is exactly the height corresponding to this horizontal value, to the vertical one, and then I have the price, for instance, $1,300,000 or in the case. So actually, and how do? You actually do trial and error. This is the idea of linear regression. That is, you start with some a line which is not well aligned, and you will try to change the angle of the line, and also change what is named the bias. That is the basic, the default value when the house size is supposedly 0. What is the kind of the value of 0 house, 0 meter square house, and then get the best possible, or one of the best possible solution. So actually, mathematically speaking, it's very simple. It's y, the value of the house, is the bias. This is a number here, plus the value of x multiplied by theta, which is actually the angle, the multiplicator of for computing the value of the house. And you could represent it graphically that way, like a sum of b, and theta multiplies x, and this gives you the value y. So this is linear regression. And I won't get into the mechanics of how you do this kind of adaptation of the finding to find the good values. This is usually named on some technique named gradient descent, that is trying to minimize the error when making the difference between the actual value and the predicted value. So for instance, here, the difference is 0 or almost 0. That is, it's a good mapping. But okay, in a real life, the variables, the criteria for the finding the price of the house is not just based on the square, on the superficie. It's also based on for instance, the neighborhood, the arrondissement, the bio, that is the place, if it's a noble, rich place, or if it's not very wealthy. Also, it could depend on the floor. That is, if you have a better view, etc. The age of of the construction or the renovation of the building or the etc. So various variables. So then the model gets a little more complex because you have not just one but various variables in input, and also it could usually in the real life. It's not a straight line. It's not linear. It's actually some curve because there's, for instance, when the price becomes very big, actually, it cannot get much bigger, and there could be some variations also. So in order to do this, you need a model which is a bit more complex, which has actually layers of this kind of weighted sum. And this is exactly what is artificial neural network. This works exactly with various layers of weighted sums. And on the output, let's take example of a classification of image of a dog or other animals. So we have a pixels for each little part of image of a dog. So every value which corresponds to a little rectangle, minimal rectangle pixel of that image corresponds to a value depending if it's white, if it's black, etc., and which will aliment these various variables, various inputs. And then there will be various successive weighted sums, layers, and at the end you have some outputs, not just one but various, and which one correspond to a class of animal recognized. For instance, dog, but also cat, elephant, etc. And for instance, in this case, if when computing successfully all the weighted sums, the value says that if we compare the values at the output and we see that the value is bigger for which corresponds to the dog, the class of the dog, we're fine. That means that the algorithm, the network, recognize actually the dog, classified correctly the dog. But if the major output, the value, the highest value corresponds to the output of a cat, then it's an error. This means that the network didn't classify it correctly. And so we need to, in a way, to correct it, saying, okay, you need to adjust, like you adjusted the angle and the bias to adjust the line for in the case of linear regression. Remember, then we need to adjust the parameters there, but there are lots of parameters in order, if we recompute, that the error being corrected and being a dog having the highest chance of being recognized, right? And we do it by successive adjustment of the weights, guided by the errors, and trying to find better values for the weights in order to minimize error. And we do it repeatedly, again and again. So it's a very simple recipe and a very brute force, actually, algorithm. And it works very well. And especially we have lots of computational power, lots of examples, a lot of data. And that's a basic. And even ChatGPT or the very more for translation are based on this very, very, very simple principle, right? So actually it's interesting because it's not that complex. So some words about creativity now. So creativity, it's also hard to define, a bit like intelligence. But if you look at practice, actually, it's not completely creative in that it's not completely, well, it's creative, but it's not completely coming from scratch. It's usually there is a level of inspiration or or maybe recopying or recombining from other works by other artists. And inspiration could be unconscious, or could be conscious, or could be plagiat, it could be also in a way assumed explicitly. For instance, Pablo Picasso said, good artists copy, great artists steal. So he said that really you need to steal actually some ideas, but you're recombining them in your own way, in your own style, the way you define your style. So and we'll see that in history there are some methods for trying to guide the creativity. For instance, the surrealist movement created what they call the cadavreski as a way to create in a sequence parts of a drawing where people didn't know what was put before by the previous artist, and it creates some very chimeric, very strange when you déplier, unfold the paper, it creates very interesting drawings which are historical. So just to show a quick example of how you can recombine styles, take some existing music and recombine with some different styles of rhythm or harmony of production. It's an example based on the Ode of Joy, which is part of Beethoven's symphony, and which is actually the hymn of Europe. This is a work by François Pachet and his team was a European ERC founded research project about named Flow Machines, about how to help musicians to create art, to create music, and based on AI techniques. And he was commissioned by the European community to in a way make some various versions of Ode à la Joie, Ode to Joy, by Beethoven, by arranged automatically by computer, by artificial intelligence, in order to show the power of AI. So let's see some examples. Let's hear. In this case, this is a reharmonization with the style of the chorale of Bach that we heard before. Harmonization has been done in automatic machine. So now it's a bossa nova style. It's using audio recording of real Brazilian guitarists. So the harmony has been rearranged on the rhythm. So the rhythmic beat automatic by the system through again learning, having been trained with various examples of bossa nova style guitar, and now I will show one more example, more lounge music style. Harder to recognize the Ode à la Joie, the Beethoven. The melody gets less important. Now it's Beatles with the style of Penny Lane. etc. So you can see the way the machine AI helps the musician, the artist, in a way to explore by doing some kind of recombinations in a way the musician has the idea and wants to test it, and the machine can do this kind of trying for him. Again, the musician will like or not the result, and can retry, readapt, build on that, correct in an interactive way the new adaptation of reorchestration and rearrangement of the music and reharmonization, etc. So neuroscience I won't talk about here today, just say that there are some interesting new findings about it. Also, you can do and there's some market for that, for some kind of elevator music, documentary, publicity, where you use AI to generate a kind of potentially endless, or you need you want to buy 2 hours, 1 minute, etc. of kind of music, arbitrarily long with some kind of style, and but usually the music created that way is not very interesting. I mean, it's interesting at the start, but it becomes a bit boring because it doesn't have much structure and kind of intention in a way. So it's to do more interesting music. It's important to keep the human in the loop, not to just replace the composer by some AI, but rather to do some co-creativity, that is to the AI to help the composer or the artist in general to explore new things. And so I will show some example of an interactive system, also by François Pachel's named the Continuator, where it is used by a musician, by a pianist, actually in a live, real time, in an interactive way. So the idea of Continuator is because the system actually will listen to what the musician plays, because the piano he will use is a MIDI piano, so it can the information about the notes when they are played, which note, etc., timing, goes to the computer. This information is used by like a kind of Markov chain is constructed online interactively by the machine, by the AI system, which in a way learns the style of the type of phrase, or the melodic style, the melodic vocabulary constructed actually on time by the online by the musician, the performer. And then when the musician stops playing, the continuator starts in a question response in a way dialogue mode, starts to continue, that is to do the continuation of what has been played. That is, tries to continue the playing. And as soon as the musician starts to play again, then the continuator stops, and then again and again. So let's see how it goes, and you will see that the musician sometimes is doing like that, like he really reflects in a way on his own playing, as the machine is some kind of mirroring, some kind of double of him, which in a way not just exactly copies what he does, but propose him some interesting new vocabulary and paths. So the pianist starts. Is a good Dutch pianist. Provides completely improvisation. Of course, just to say, complete improvisation. It's like a composition, like it's another way of, it's online composition actually. It's like for creativity, it's creative, it's creating his own, but of course it's based on his memory and his vocabulary acquired through lots of listening to music, to play, and to etc., and to learn, to train also about harmony, etc. So now start playing. You can see the keys on the pianos. The keys on the piano could be controlled by MIDI by the computer. Some kind of really transposition of the melodic element and harmonic. Now it's the other way around the continuation. That is the pianist started to continue from the continuation by the machine actually, and then it's back to the machine. So it's a fantastic way, a tool actually to help you to rethink about yourself, your way of playing in your vocabulary. The head of the pianist, Albert, is interesting. He's finding some interesting and surprising for him, because in a way it comes from him, and at the same time it's something new. So that's usually creative stuff. It's what we would like, something in a way coming from us at some point new, and also of course interesting. So it means within our kind of our style. So it's a balance between going outside the comfort zone and at the same time staying within the cultural kind of an interesting zone, right? Exploring. So so now I will skip this. This is another example of a tool for composition. I would just to finish give a few ideas about the problem of authorship and copyrights, because for music and for other medium, for other types of art, because of course the fact of using a machine, especially these new techniques, create a big tension on the standard models of copyright and authorship. So actually, at first, we could we need to think about ourselves and what is our model of creation, because in the history, for instance, there has been some funny artist painters in France in the starting of the 19th century, which had the idea of putting a pencil attached to the tail of a donkey, and putting the pencil onto from time to time onto colors, and making the donkey paint, and they named the painting "Et le soleil s'endormit sur l'Adriatique." So, and they named the donkey Lolo. And so, who can create? And for instance, a GPT, even before ChatGPT, at some point created that following phrase: "Music is the most advanced form of mathematics," which I find very interesting. In a way, it's a creative content, and the machine created it. So, but about copyrights, of course, this creates problem, because as the machine will learn a lot from existing musics or paintings or etc., that you alimент it with to train it to learn styles, what is the contribution of this for the final result? The final result, it's likely that there won't be a standard plagiat. There is a exact recopy of some sequence of notes from the existing from the training corpus. So and comparing the sequence of notes, for instance, in jurisprudence decision, sequence of 3 notes was sufficient for the process, the juridical process, to decide that there was some copyright infringement. But for these new techniques, which are no more based on the kind of rearrangement of sequence of text, of notes, etc., it's more hard to say what is exactly a copyright infringement. Also, when a sampler uses sounds, for instance, to make music, if it's a little piece of sample of existing music, yes, it's possible. But if it's completely regenerated and in a different way, completely regeneration through the inspiration by AI machine, then it's difficult to say what is a copy, what is a copyright on this. One interesting thing is that there is some convention which is quite old, from 18th century, 1886, a Berne Convention, which says that there is a necessary presence of a curator, of a human, to be able to copyright the music. To put it on to some editor and some musician rights corpus, actually, basis. So this, or at least until now, this forbids the possibility of putting the name of a machine as an author for composition. But we are not sure that it will remain always the case. And again, there will be more information about that, discussion about this question of rights and authorship in the cycle of seminar cycle. There will be Jean-Marc Delton, who is a specialist about rights for an authorship for music, who will give a specific seminar on this in, if I remember well, will be in October. So please stay tuned. Continue to see this series of seminars, because there's a lot of more interesting things and more details that today I just kind of surveyed as an introduction to the cycle of seminars. Will come soon. So to conclude briefly, it's of course it's a huge power that we have now with these new AI techniques. Again, a big reminder that it's not just one type of technique. It's a toolbox. There are several kinds of ways to use it. This also forces us to rethink about our notion of intelligence and creativity. We'll discuss it more further in the next seminars. For me and for most of the people in this field of generative AI for art, we think it's interesting and important to keep the human being in the loop. That otherwise it's not very interesting to do some kind of completely automated generation, and the result usually is not very, very interesting. What is more interesting is to help artists to do it better, to do it further without the use things that they wouldn't do without the use of AI. And in order for more general statement also is that in order for us as human beings not to be too much following the big players, decision, and in a way be passive in front of these new techniques, it's important to understand not necessarily all the techniques, of course, details, but at least the basics. So it's part of the objective also of this cycle of seminars, give a little bit of insights and for everybody to empower himself actually about the potential use of these techniques, the goods and the potential risk, and to be of alienation. So of course for this we need more education and appropriation by ourselves and more experience about the usage, because these are very powerful tools, but the way they are used by humans is of course fundamental. They could be used in productive ways and for everybody, and could be used also in less interesting and useful and more potentially harmful ways. And again, this is most of these topics will be more addressed further deeper in the following seminars. And so please stay tuned. And the seminar by Alexandre is following soon, and there will be further. These are some references, and I will stop here, and I will thank you for being there, for attending. I hope you like this introduction to the cycle of seminars and the series, and I hope you can continue to follow us and participate, because it will be open for questions, comments, and questions via YouTube comments. So thanks a lot, and see you soon again. And of course, you could replay anytime this first seminar on YouTube. So à bientôt, bye bye now. So à te breve, à bientôt.